Welcome to Unit 13, Understanding the Equal Sign. This will be a two-part video. The first video will actually focus just on the first no of the unit to determine if the equations are equal, if they're true or not, or equal or not. And then the second video will focus on the missing addends. So we're going to start here looking at 7 equals 8 minus 1. So to be able to make this concretely and do this concretely for the students, I know a lot of you like to use the balance scales, and that's great, but a way to move them from the balance scales where they're modeling that and getting them to paper and pencil with some manipulatives, this would be where you could go from there. So I would want to represent 7. We also want to make sure that students see like here that the difference is first, the difference is equal to 8 minus 1, and make sure they see that with addition as well. You don't always want the 8 minus 1 on the left. You want them to see it on both sides. So we're going to represent 7. So I'm going to put 7 here. And these little blocks just kind of help students that maybe need to be able to help keep them organized. You could eventually move to where you don't have these and they could just have on this a piece of paper and just put the equal sign there, but these may help them keep it organized. So then I'm going to represent 8, and I've got a group of 10. I know that if I take 2 away that I've got 8, but then I have to take away 1, and then I want to look and see if they're equal. They should have the same value, and they should be just as long if they started at the same point. And so 7 equals 8 minus 1, which is 7 as well. All right, another way that we can represent this is using some 10 frames. So we have now moved from just having the difference to having equations on both sides. So 4 plus 5, so I'd want to represent 4 plus 5. So I have 4 on this side, and then I'm going to add 5 more to that. So I know that, go ahead and fill that top row in. Organize that a little bit better so I can see that that's 9. So then if I come over here and I represent 1 and then I add 3 more, I can look and see easily that that's 9 because I have one open spot there at that 10 frame, and I can see that that's 4. And so that would not be equal, that would not be true, that would be false. Eventually, we want to step up to some larger numbers, and we want to mix addition and subtraction together. So we'd want to have 12. So if I represent 12, which means that my whole 10 frame is going to be complete on this one, and then I'm going to have 2 more down below. And then I'm going to take away 7. So if I think of a 7 as a 5 and a 2, I can go ahead and take away 2 from here and take away the 5 from this 10 frame, and I have 5 left. So then I want to represent 9 plus 8. So I know that 9 means I'm going to have 1 of my 10 frame spots not completely filled in, and then I'm going to add on 8 more to that. So put that there. Now 8 I can think of as a 7 and 1. I filled in 1, so I would need 7 of them down here, which would mean my top row is completely filled, and 2 more here, which would give me 8, which is 17. So 5, is that the same as 17? No, it is not. That would be false. Now, finally, let's look at how students can model this on their own paper, because you want to start with manipulatives, but then eventually they need to be able to solve this without having the manipulatives. So they can have a little equal sign on their paper. They can use lined paper. You might want to start there, and then they could just do blank paper as well. But it's going to be important that they make whatever object they draw to represent the numbers the same size. So if I have 7 minus 3, I'm going to put 7 x's. And then I'm going to take 3 of those away. And then I'm going to make 8 x's. And I'm going to take 6 of those away. 1, 2, 3, 4, 5, 6. And then I can see that this is 4 is equal to 2, which that is not the same as. So that would be false.